Hello students, welcome to the next lecture on the complex analysis. Today we will discuss about harmonic function and conjugate harmonic function. Myself Dr. Harish. You can simply follow my YouTube channel for finding the various videos on this mathematics 1. What we have discussed so far, we have covered the analytic functions and the CR equations are there. Now we will try to learn one more term or called as a more function which is closely related to the analytic function named as harmonic function. So before I start with the harmonic function, let's first discuss what is a Laplacian operator, or it is a differential operator which is defined like here. So you can say it is nothing but del dot del, where del is your vector quantity which is written like here. This is I cap plus j cap. So we all know how you can take that dot product. You can write like this man. Then based on this we can say any of the functions, say h of the two variable, is said to be harmonic. First of all, this h is the continuous partial order, second order continuous derivative, and satisfied this equation, that is this Laplacian operator. If you define on the h, then it must be the 0 is called as the Laplace, is called as the harmonic function. As we have discussed that f of z is u plus iota v is analytic function, then the properties of this u and v are satisfy the harmonic function. That means this u satisfied this property, then it's a harmonic function. Also the v is also satisfied this property. So remember, this is one of the most important property in the complex analysis. If you have the analytic function, then the real component of the f and the imaginary component will satisfy individually as the harmonic function. The proof is very simple. If you look at this statement, f is analytic. What is the meaning of the analytic? So if f is analytic function, it means it is a differentiable. Fine. While we have already discussed the converse is not true. So if f is analytic, then it has an infinitely many time continuous differentiable and satisfy the CR equation. If it is infinitely many time continuous differentiable, then by the properties you can say partial derivative of u with respect to x and y is nothing but y with respect to x. They are the same thing and satisfy the CR equation. Then our target, what is our target is? Your target is to prove u is my harmonic. That is your target. So for that you need to prove this value. So your target is to prove this must be 0. Similarly for the v. So let's start with this first part. So can I write this partial derivative as of this nature? Fine. Now I can substitute the value of the del u by del x from here, which is, this is nothing but my del v upon del y. Fine. Sorry, this is x, partial derivative with respect to x. Fine. Similarly, you can find the del y. First of all, this is nothing but del square v over del x del y. I can write this part also. This is del u over del y. So I can find the value of the del u over del y here. So which is minus del square v over del here. Fine. Now you can see if you add them, what will happen if you add them? This will be the 0 because of this property. So because it's a u as well as v also. So you can see if you adding, it means u satisfied harmonic function. Similarly, u satisfied harmonic. Similarly, you can prove for the v. V is also satisfied the harmonic function. Remember that if f is analytic function, then f and v both are the harmonic function. So if in such case, if this case will happen, then you can say u and v are the conjugate harmonic function, or you can simply say conjugate function. So what is the definition of the harmonic function is? Harmonic conjugate function, v is said to be the harmonic conjugate function if u and v both satisfy the harmonic function, that is this property satisfied, and satisfy the CR equation, Cauchy-Riemann equation. Remember, if v is the harmonic conjugate of the u, then it is not always true that u is also the harmonic conjugate of v. Proof is very simple. what is given to you? V is a harmonic conjugate. What is the meaning of the harmonic conjugate? That means this plus is satisfied and V satisfied my CR equation. That's the properties of this. That means V satisfy the Laplace equation. Laplace equation means Vxx plus Vyy is equal to 0 and satisfy the CR equation. Then your target is to prove whether U is a harmonic conjugate or not. So for that you need to prove U satisfies harmonic function, number one. Second is this must satisfy. But clearly says, if you look about that, from the equation 1 you can see this is the positive sign, but from the equation 1 it's a negative sign. It means they can never be equal. So clearly says this is not always true unless the function is constant. So whenever the function is not a constant, then this result will not hold from this equation number 1. Hence, in general we can say V of x is not equal to U of y, V of y is not equal to minus V of x. Hence, it is not always true that if V is the harmonic conjugate of U, then U is also the harmonic conjugate of V. Another result is, if V is the harmonic conjugate of U, U is also the harmonic conjugate of V, then U and V both are my constants. Another, if V is the harmonic conjugate of U, then minus of U is the harmonic conjugate of V. As I see in the previous one, if V is the harmonic conjugate of U, then U is not the harmonic conjugate of V, but minus of U is the harmonic conjugate of V. Proof is very simple. What is the meaning of that? V is the harmonic conjugate of V, U. It means it satisfies the CR equation. Similarly, U is the harmonic conjugate of V. Again, it satisfies the CR equation, which is here. So can you say from both sides, like U of x, if I substitute here, can you solve these two equations? What do you get? You will get both as my 0. Similarly, if you solve these two equations, what you get is a Vx is nothing but Uy is 0. So that's the meaning of this. So what is that? If the partial derivative is my 0, what is the meaning of that? U and V both are my constant functions. So that's the first part. Look at this one. If V is a harmonic conjugate of U, so it means V satisfies the Laplace and the CR equation. Your target is to prove minus of U is the harmonic conjugate. That means your target is to prove it satisfies the Laplace equation and it satisfied my here. So clearly says, can I write this function as minus of Uy, and minus of U I can return this as of here, which is similar to this one. Similarly, from here I can multiply this minus. You can see it is a harmonic conjugate. Now let's see what is the results are there. So if U is the harmonic and V is the harmonic, then V is the conjugate, then V is also the harmonic. Harmonic conjugate is not symmetric, as I gave you the simple example. If V is the harmonic conjugate, then minus of U is the harmonic conjugate. So this implies if U plus iota V, if I multiply by iota on the both sides, then you will get this is also the harmonic. Now let's see how you can find. So how to find conjugate harmonic function. How you find the conjugate harmonic function means if the function is U is given to you, how you can find the value of V. So let's start with this. So show that the function is harmonic and find the corresponding harmonic function V. So what you want to prove? Your target is to prove the harmonic function as here. So U is given to you. You can find the partial derivative with respect to x. What is that? It's a 2y plus 2. You can find the partial derivative second time because we need a second derivative. It's a 0. You can find the partial derivative with respect to y. It is my 2x. You can find the partial derivative twice. So it will be 0. And clearly says that if you add them, you will get as a 0 is the right answer. So therefore, U is my harmonic function. Now the question arises is how you can find the conjugate harmonic. So we always use the CR equations. Fine. So now you can see what is the value of the del U by del X. It's a 2y plus of 2. What is that partial derivative of this with respect to y? We have a 2 of x, so I can substitute here. Now from this side I can integrate with respect to y on the both side. So what will happen? If you integrate y on the both side, it is a v. This is my y square. This is my 2 of y plus constant. So here it is integration with respect to y. So constant is my function of the x. So we can say g of x is a function of the x. Now I can substitute this v value in here. So what is the answer of this? You have to partial derivative with respect to x. It's a 0. It's a 0. It's a minus g dash x is equal to 2x. So can you find the value of the g from here? You can integrate them. So g of x is x square plus constant, or g of x is nothing but my minus x square plus of c is the required. I can substitute this value g as here. You will get v is the harmonic conjugate. You can also check your answer in the examination that whether vxx plus vyy is 0. If this is not hold, then your answer will be wrong. You can see what is a vx, partial derivative with respect to here. What is a vy, partial derivative with respect to y is here. Now you have to find the vxx. Vxx is my minus of 2, vyy is my 2. You can see if you add them, it's a 0. It will, this answer is correct. Okay, look at the next one. Check which of the following functions are harmonic. If yes, then find the conjugate harmonic v. Very simple. We can start with the first part. So for the harmonic function, we need to prove this. Find partial derivative with respect to x. Find the partial derivative with respect to y. You will get as here. Now you can find the uxx. What is the uxx? Is minus 6y. What is the uyy? You can take the partial derivative with respect to y is a 6y. So clearly says that if you add them, you will get as a 0 is the right answer. So u is my harmonic function. Once it's a harmonic function, then we can find the value of the v by using CR equation. Now you can see partial derivative of u with respect to x we have, partial derivative of u with respect to y again we have. So I can substitute the values as here. Fine. Now you can see this is a function of the x and y both. I can you can either integrate with respect to x, or you can integrate this with respect to y. That's on your choice. So let's say I can integrate this part with respect to x, keeping y as a constant. So what is the integration of this? Is a minus 3x square, and integration of the minus 3x square is x cube plus, see, because we integrate with respect to x, so keeping y as a constant. I can substitute this value of the v as here. Now you can take the partial derivative with respect to y. So minus 6xy plus 0 plus g dash of y is minus 6xy. So clearly says that this will be cancelled out. So g dash will be my 0. So g dash 0 means g of y is my c is the constant function. Substitute this value as here. You will get v as my harmonic function. Again, you can check your answer in your examination. How you can check that? You can find the value of the vx. It is my minus 3y square plus 3x square. Find the value of the v of y. It is minus 6xy. Find the vxx. It is 6x. Find the vyy, minus of 6x. If you add them, you can see it's a 0. So therefore this answer is correct. Look at the second part. How you can do that? Again, your target is to firstly find the partial derivative of u with respect to x and u with respect to y. So you will get as here. Then find again the partial derivatives, and you can see this property satisfied. Fine. How you find the harmonic conjugate harmonic? We can again apply the CR equation. I can substitute the values of u and u of y as here. I can integrate this with respect to x. Fine. So what is that? It's a v. Integrate with respect to x. So it's a 3x square y plus integration constant value of y. Fine. It's a function of y. Substitute this value of y as here. So what will happen? Partial derivative with respect to y. So 3x square plus g dash of y is 3x square minus 3y square plus 3. So you can see it will be cancelled out. So remember, now it's a function of the y always. If this will not be cancelled, make sure your calculation, you can recheck your calculation because it will not be happen so. So you can see it is here. Now how you can solve? Because it's a derivative, you can integrate them. So what is the integration of this? It's a minus y cube plus 3y plus constant. So you can see here, substitute the value this, you will get v as this answer. You can easily check your answer whether this property will satisfied or not, that is the Laplace harmonic function will satisfied or not. Look at the third option. Now again, for that you have to firstly find the partial derivative, and then you can easily see if you add them you will get as a 0. How you can find the conjugate harmonic? Again we will apply this CR equation. I can substitute this value here, you will get this one. Now you can integrate this with respect to x. So this part is, so this sine hyperbolic y is my constant which is outside. So what is the integration of the sine x is? Minus of cos x. So it is a plus g of y, where g of y is a function of the y. Substitute this value as here, partial derivative with respect to y. So if you take the partial derivative with respect to y, partial derivative of sine is cos hyperbolic. You can see it is a cancel out. So g dash of y is my 0. So gy is my constant. So I can substitute here, you will get as the conjugate harmonic function. Look at the another question. Show that the function is harmonic and find the conjugate harmonic. The first part is very simple. You can simply take the partial derivative 2 times and you can see the sum is a 0, so it's a harmonic function. For the conjugate harmonic function, again we are using this CR equation. I can substitute the value of u and here, so you will get this. I can integrate this with respect to x, so you will get as of this term. Substitute this value as here and you can simplify this. 3x square will be cancelled out. Now you can integrate them, you will get g of y is minus y cube plus c. Now you can substitute this value as here, you will get the answer as conjugate harmonic function. Now look at this another one. Consider a function is there, you have to show that it's a harmonic. So again, the first one is you have to satisfy this property, partial derivative of u with respect to x, partial derivative of u with respect to y. What is the second derivative? Is e raised to power x is same. What is the second derivative of u with respect to y? Is minus e raised to power x cos y. You can see if you add them you will get as a 0 is the right answer. How you find the conjugate harmonic? Again we are using the CR equation. We can substitute the value of the partial derivative of u with respect to x and y here. Now this is with respect to y, so I can integrate with respect to y on here. So it is v. What is the integration of cos y, sorry, it's a sine y plus function of the x. Fine, because we integrate with respect to y. Now I can substitute here, this is a partial derivative of v with respect to x. So e raised to power x sine y plus g dash of x is minus ex sine y. Fine, sorry, it's a plus sign are there, so you can substitute here. So it is a cancel out. So what is that? G dash of x is my 0, so g is my constant. I can substitute the value here, you will get this as the right answer of this problem. Now look at this another result. Prove that the harmonic function satisfied this equation. Okay, so what is that? Harmonic function is given to you. It means this is already a given to you. Let u is the harmonic function, satisfied this one. Now here you can see it means we need to firstly find this term. Fine, and it's a function of the u is a function of the x and y. So I must find the function firstly of z bar with respect to x. So what is a z bar? It is x minus iota y. Fine. So if I add them, can you find the value of the x from here? I can simply write that. Okay. And if you subtract them, what will happen? You will get as of y. Fine. So I can write this from this term and I can simplify this. So therefore I can firstly write this quantity. How I can write that? So you can see by using the chain rule, I need u is the function of the x, u is the function of the y, which can be written like here. So what is that? This is nothing but partial derivative with respect to x. This is the partial derivative with respect to x bar. So I can written this as this multiplied by x over z bar, plus on this second side partial derivative with respect to y, and this is y with respect to z bar, plus of this y over z bar. Fine. Now I can substitute these values. What is the value of this? You can see what is the partial derivative of x with respect to z bar? It's a half. What is the y with respect to the z bar? It's a minus 1 over 2 iota. So I can substitute here. Now in order to find this, now I have to take this value. Fine. So this means the complete value. So half I can take it as outside. So this is partial derivative of u with respect to x, minus 1 by 2 iota is outside, half partial derivative of u with respect to y. So now I can again convert this term, that is I can again change this term into here. How? You can see I can change this term, partial derivative of u, I can write like this way. Fine. So I can change like of this value. I can differentiate this with respect to x firstly and then with respect to z. Similarly, I can break this part with respect to the z term as of this. Now again we can substitute the values. What is the value of this? Partial derivative of x with respect to z is again half, y with respect to z, y with respect to z is 1 by 2 iota, y with respect to z, and x with respect to z r. Now if you open this bracket, you can see this part will be cancelled out. It's a 2 iota, it's a 4 iota cancel out. The rest of the part is same. And since u is harmonic, so uxx plus uyy is my 0 is the required class. Okay, look at this another one. If u is given to be here, v is given to this, show that u and v satisfy the Laplace equation. Laplace equation means this satisfied, or you can say the harmonic are there. But u plus iota v is not an analytic function. So the first part is very simple. U is given to you as x square minus y square. You can find the value of this. You can find the value of this easily, and you can start with this. So what is the uxx? It is my 2. Uyy, it's a minus of 2. So clearly says that u satisfied my Laplace equation. Similarly, for the v, we have the value of the v as minus y over x square plus y square. Can you find the value of the del v by del x? You can apply the u over v, so you can get as v of x as here. Similarly, you can find the partial derivative of this y with respect to x. You can apply this as a derivative rule. Now you can find the v of x and v of y. So you can see, you can apply the u over v rule, which is as here, and v y is by this. So therefore vxx plus v y, if you add them, you can see the LCM are common. So if you add them, it's a 0. So therefore v also satisfied my Laplace equation. Now the second part is u plus iota v is not analytic function. So how you can prove that it's a not analytic function? So in order to check whether it's analytic or not, we need to check about the CR equation. Fine. So we have to find the ux, we have to find the vy, and check whether they are equal or not. So that we already found that this is my ux, this is my vy, this is my vy. Are they equal? They are not same. So it means you can clearly say ux and vy are not same. So therefore they are not satisfied the CR equation. Hence it is not an analytic function. Fine. Okay, look at this another one. U is given to you. Whether U is a harmonic or not, it is not given to you. So you have to firstly check whether uxx plus uyy is 0 or not, because you need to find the analytic function. So if this is analytic function, then u and v both satisfy the harmonic function. That's my other property. It means you need to firstly check whether u is the harmonic or not. So you can find this, you can find this, you can see partial derivative with respect to x square. So if you take them, it's a 6x minus 1. If you take the partial derivative with respect to y, so it's a minus 6x plus 6. You can see that if you add them, it's a 0. So therefore u is my harmonic. Fine. So once it's a harmonic, then you can find the value of the v by using the CR equation. I can substitute the value of the del u by del y from here, del u by del x from here, so which is this one. Now I can integrate this term, with respect to x. So what will happen? V, it is my 3x square y minus 6xy plus g of y. Clear? You can see that how you can integrate this term minus of 6y with respect to x. So what is that? 6y is constant, x is my x square over 2, 6y is my constant, integration of the 1 is my x. So it is a 6xy, it's a 3y square. I can substitute this value in my second equation, partial derivative of this v with respect to y. So it is 3x square minus 6x plus g dash of y is 3 times x minus 1 whole square minus 3y square. So since it is a value of the g dash y, so this term must be cancelled out. So if you open this bracket, what will happen? It's a 3x square minus 6x plus of 3 minus 3y square. You can see that x term will be cancelled out. If it is not cancelled out, you can check your calculation. It means something is wrong if will not be cancelled out. So your g dash y is nothing but my here. Now you can integrate them. What is my g of y? Integration with respect to y is a 3y, it's a y cube plus c. Substitute this value as here, you will get as the harmonic function. So therefore u is my here, v is my this. You can find the analytic function as of this. Also you can check your answer by on whether vxx plus vyy is 0 or not. It must be there. If it is not, then your again calculation is missed. Okay, next one is show that this is a harmonic and find the conjugate harmonic function. It's a similar. You can start with the partial derivative. You can see that if you add them, you will get as a 0. So it's a harmonic function. How you can find the conjugate harmonic? Again, we can start with the CR equation. I can substitute both the values as here. I can integrate this with respect to the x. You can get as a constant of y. Substitute this value as here. You will get this expression. So 3x square will be cancelled out. This will be cancelled out. Only term is here. Now you can integrate them. What is the g of y? Is minus y cube plus c. Substitute this value here. You will get as conjugate harmonic function. Okay, look at this another category. If you have the two function phi and psi which satisfy the Laplace equation, what is the meaning of that? Del square phi, if it satisfied the Laplace equation, that means this is a 0, and psi also satisfied, so this is a 0. This is given to you. This is given to you in the first line. Then show that s plus t is holomorphic. Holomorphic means that is an analytic. Show that s plus t, where s and t are here, is a holomorphic function. So what is the meaning of that? Your target is to prove, you have to check whether it's a satisfied CR equations or not. So as I told you, is satisfy the Laplace equation, this is given to you. Your target is to check whether s plus t is an analytic function or not. We need to check the CR equations. So if it is just like say u plus iota v, then my CR equation is ux is equal to vy, u of y is minus of vx, but here it is a s and t. So what is that? This is s of x is equal to t of y, fine, and s of y is minus of t of x. That is the purpose we need to check them. I can return this s of x is nothing but my here. So I can start with the left hand side. Partial derivative of this with respect to s. S I have already given, so I can start with this case. Similarly, for second case, I have the value of the t, I can return like of this one. Now you can open this bracket, I can return like this one. Similarly, I can substitute this value as of t here, which is this one. Now we need to prove both are equal. How you can prove that? If I subtract them, what will happen? On the left hand side, this minus of this. So clearly say that they are cancel out because it satisfies the Laplace equation. The difference of them will be del square phi over del x square minus del square psi over del y square. Fine. So I can take a minus as a common. So this value I already given as a Laplace equation. So the right hand side is my 0. So the difference of them is a 0. It means they are same. Fine. Similarly, for the second side, I need to prove that del s by del y. So I can take this s with respect to y and t with respect to the x. So you can open this bracket, you will get here. Similarly, I can substitute this value, you will get this as expression. Now since I need a negative sign, so I can simply add them. What will happen if you add them? Partial derivative s with respect to y, t with respect to x. So clearly says that this term will be cancelled out, and if you add them, partial derivative with respect to x square with respect to y square. So you can see this term is given to you as a 0. So this is also 0. Hence we can say this results hold. So therefore, thus what is the meaning of that? S and t satisfied my CR equation. Fine. So therefore it is my holomorphic function. That's true. You also need to prove that whether their partial derivatives are continuous or not, but it is already satisfied the Laplace equation, so it is a s and t are satisfied by continuous partial derivatives. So this is the way you can solve all these harmonic functions and develop the conjugate harmonic function. In the next lecture, based on this harmonic function, we can construct how you can construct the analytical function. We will describe the 3 different methods. That is our next lecture. Till then, you can simply like, share and comments on my video. Best of luck, students. Happy learning.